32, 33, standard form. All right, so we've been working with, for the last week, we've been working with slope-intercept form. And slope-intercept form is y equals mx plus b. And we even talked about yesterday in slope-intercept form when we were graphing our linear equations, right? The graph of this is a line. And we know that it's a diagonal line because it has a y and an x. If the equation just had the variable y, what specific type of line is it? Horizontal. And if the equation just had an x, it was vertical. But if it has a y and an x, it's a diagonal line. It could be really steep or it could not be very steep. It could be positive, it could be negative. But having both variables makes it a diagonal line. It's linear, makes a line, and it is diagonal because it has both of those. So an equation, right? A line, the graph, what we're going to use to make our graph, could be written in standard form. Or it can be written in this thing called, or slope-intercept form, or it could be written in standard form. So there are two ways to write this equation. The easiest is slope-intercept form because it doesn't involve really any manipulation. It's just right there in front of you. M is your slope and B is your intercept. Or it could be written in a different way. It could be written in something called standard form. And standard form is AX plus BY equals C. Now here's the part about this that I really don't like. So we have to address it right now. This is still a linear equation. It's going to make a line if we graphed it. And you know how I know it's going to make a line if we graph it? It has an x and a y. If it has an x and a y in the equation, it makes a diagonal line. We're good to go. So this is still going to create the same type of line that we've been dealing with. My problem with this equation, the way that it's set up, are my variables. Because if you look at this equation and you look at this equation, they're different, aren't they? The extra variables. Yes, they both have an x and they both have a y, but they also include different letters. The b in standard form is not the same b in slope-intercept form. Okay? They represent, they're two different things. So they do not represent this, like this b is not the y-intercept. Okay? This b is not the same b as up here, the y-intercept. They're completely separate. The a value is the coefficient of x. The b value is the coefficient of y. And the c is the constant. Or it's an integer. It has nothing with it. A is your coefficient of x, B is your coefficient of y, and C is your constant or your integer. For example, if I gave you something written in standard form, (3x plus 4y equals 10). That's linear. It has an x and a y. So eventually, if I was going to graph this, it would make a diagonal line. And I know it's diagonal because it has the x and the y, right? But my a value is 3. My b value is 4. And my c value is 10. So both of these make lines. If we were going to graph them, they both make lines. So they're both y equals mx plus b and ax plus by equals c. So slope-intercept form and standard form are both linear equations or functions. So what we're going to do today is we're going to practice. We're going to start identifying, is that equation a linear equation? Will it make a line? Will that equation that you're given make a line? So if it's in equation form, we're going to figure it out. If it's in table form, or if it's a graph. And graphs are obviously the easiest, because if you're looking at a graph, can you tell, does it make a line? Hello? Yeah. I mean, if you're looking at a graph, is it pretty easy to say, yes, that's a line? Yeah. Or no, that's not a line? Halloween candy rot all of our brains?
No.
I'd like 4.
I know, I'd like to. I haven't really had it.
All right, so the requirements for an equation. If you're given an equation and it's asking you, is this a linear function? Or is this linear? If it's in equation form, here are the requirements. There can be no exponents. If there is an exponent in your equation, it's nonlinear. So 3x squared equals 19. No, that doesn't work. There's an exponent in it. It's not linear. There can be no absolute value. So like the absolute value of x minus 4 plus y equals 10. Nope. Not linear. There can be no square roots. X minus 10 equals y. Now, here's my question. The exponent is touching the variable, right? The absolute value is touching the variable. The square root is touching the variable. So there's no exponents, no absolute value, no square roots touching the variable. Because if your problem looked like this, y equals 3/4 x plus the square root of 64. This is different than this. Why is this different than this? Jamie, why? It's touching a variable here. And I don't know what the square root of x is. Do you know what the square root of x is? But over here, do you know what the square root of 64 is? What? right? So this is different than this, yes? If you had a problem that said 3x plus 10y equals the absolute value of 13.
What? Yeah.
Because what's the absolute value of 13?
13.
So 3x plus 10y equals 13. Those are the same, right? Different than this one because the absolute value is dealing with an x, correct? Okay. There can be no variables in the denominator. And there can be no variable times a variable, like x times y, combined variables. If your equation meets the requirements, there are no exponents, no absolute value, no square roots, no variables in the denominator, no variable times a variable, it's linear. So you can look at it and use these tools to help you. If it's a table, every line we graphed, we used 2 items to graph it, didn't we? Every line we've been graphing, there are 2 requirements that we had to identify in order to graph it. What were the 2 things we had to look at and find in order to graph? So where it started, the y-intercept, and the slope. And the slope is the what? What is slope? Steepness of a hill. So what formula or what? How do you describe? What's the formula, the definition? Change in y over change in x. So if there's a table, it has to have a constant slope, meaning change in y over change in x. And we can easily find that out. It's just subtracting. Now let's talk graph. If you have a graph, how can you tell your graph is a linear equation? If you have a graph of a thing, how can you tell if the graph you just made is a linear equation? Kevin? It makes a line. You don't need to say it makes a straight line because guess what a line is? A line is straight. Did you know that?
Wow.
I know. It's one of those things that you'll start hearing. It makes a straight line. Well, duh. That's what a line is. It's like when newscasters say that the car was driving at a high rate of speed. There's no such thing as a rate of speed. Speed is a rate. Driving at a high speed of speed. If it makes a straight line, it makes a line.
I need 7th grade orchestra students to go down to the gym at this
All right, let's
time
practice.
for pictures. 7th grade orchestra students.
Copy these tables. We're gonna practice. This is from a table, So copy these, and then we'll use our table rules that we just wrote on the previous page. Copy these two tables, and we're going to determine, are these two tables, do these tables represent a linear equation? Do these tables represent a linear equation? Do these tables represent a linear equation? All right, what's the rule for a table? Looking at what we just wrote on page 32, when you're given a table, how do you determine, is this, I mean, could you draw a graph and plot the points and connect them? Sounds like a lot of work. How can you determine, is this
As a constant slope.
constant slope? So how do you do that? What does that mean? What?
Change in y over change
Change in y over change in x. So here we go. What's this change?
2.
What's this change?
2.
What's this change?
2.
What's this change? What's this change?
1. 1.
Is the change in y over change in x constant? Yes, this is linear. The slope is what? No. The slope is constant. What is the constant slope? Give me a value.
1/2.
No.
What?
2 over 1, which is
2.
2. Change in y over change in x. Change in y
Change in y.
over change in x. Y over x. Y over x. Yes? Every time. All right, let's do this one. What's this change? This change. This one. This one. Looking good, right? What's this change?
3.
What's this one? 5. Stop. Are these proportionate? 1 over 3, is it proportionate to 1 over 5?
No.
So is this linear?
No.
We're going to do 3 graphs. They do not have to be beautiful. Three graphs. They do not have to be beautiful. I mean, if you want them to be beautiful, if your time, not mine. We'll move on without you. Three graphs. Are they linear? Are these linear equations? How about this first guy? Is this a linear equation? No. Why not?
Doesn't make a line.
It's not a line. It's not a straight line, right? Line. It's a curvy line. It's not linear. How about this guy? No, why not? It's not a line. A line must be straight, correct? Is this straight? No, it goes down and then up. Does this have a constant slope? No, it's negative, and then the slope changes to positive. That's not the same slope. This one, does this have the same slope? No, it keeps changing, right? This guy, is this a linear equation?
Maybe.
Why?
It's a line.
Yes. Yes.
Because it has a constant slope, correct? I mean, we can't count it because there aren't values, but you go up 1, 2 over 1, 2, up 1, 2 over 1, 2, up 1, 2 over 1, right? The slope is constant. Let's try these. Are these linear equations? Look at your rules for linear equations. Is 2x plus 3y equals 5 a linear equation? Yes. In fact, it's written in what? It's written in standard form. Is x squared plus 3y equals 10 a linear equation?
No.
Why not? Good. Is, this one's a tricky one, 2y equals 8 a linear equation?
No.
Yeah.
No.
Okay, what variable's in it?
Only one.
Only y. If there's x and y, it means it's diagonal. But does it have to be diagonal to be linear?
No.
If there's just a y, what kind of line is it?
Horizontal.
Horizontal. Is this a line?
Yeah.
If you were going to simplify this, what would it be? Y equals what? Solve for y. What?
4.
Y equals 4. Could you graph that? Perfect. All right, let's try one more type. I want you to write in standard form and identify A, B, and C. I want you to write these in standard form and identify the A, the B, and the C. Whew. Almost ran out of room. Standard form. Standard form is ax plus by equals c, meaning the integer is by itself and the x and the y are on the same side. Standard form, the x and y are on the same side, the c is by itself. C is all alone, x and y are together. So if I look at this first problem, I need to move what? To get x and y on the same side and c by itself, what should I move?
One.
You could move y, but then you'd have to do some more moving, right? There's one thing that you can move.
To X.
I can move the x over to this side, correct? How do you move 4x? Minus 4x and minus 4x. Can you do y minus 4x? So what should we write? I'm going to put negative 4x plus y. Is that the same thing as y minus 4x? Equals what? 2. What's the a? Negative 4. What's the b? 1. And what's the c? 2. X equals 7. Write it in standard form. The x and the y need to be on the same side. Anything we need to move? Is there anything we need to move? No. Is this a linear equation?
No.
What kind of line is it? Vertical, because there's only an x. But there is no y, so I can't move anything, correct? So what's my a? What's the coefficient of x? 1. What's my b? What's the coefficient of y? 0. And what's my c? Good. Last one, lots of work to do. What should we move? We need x and y on the same side. Okay, let's move this 2y over here. Does that sound good? Minus 2y. Oh, and I can put it with this one, right? Minus 2y, because that's a 1. Yes? What do we get when we simplify? Does the 3x change? Does the minus 5 change? What's 1y minus 2y's? Negative 1y equals, what's left over here? Negative 4. Am I done? What else do I need to do? So plus 5 and plus 5. Does the 3x change? That disappears. Negative 1y, does it change? Equals negative 4 plus 5 is?
Okay, now we need 8th grade orchestra students to report to the orchestra
What's
room.
the A?
8th grade students report to the orchestra
What's the
room.
B?
-1.
And what's the C? Perfect.